right, problem number 43. There we go. In the figure, Vx is perpendicular to Wz. So using this information right here, I know that this is perpendicular to this. Perpendicular means forms a right angle. So there is a right angle on either side of xv. And then it also tells me that wy is congruent to yz. So this segment right here is congruent to this segment, which means that y has to be the midpoint. Because the two segments on either side of y are the same size, and w, y, and z are all collinear. First question then for part A is, what is the name of Vy? Vy goes from a vertex to the midpoint. And so that means it is called a median. Name of Vx. Vx, this guy right here, goes from a vertex to the opposite side. And makes a 90-degree angle with the opposite side. Because it makes a 90-degree angle with the opposite side, and because it starts at a vertex, that means this is an altitude. If the measure of angle WXV is 3x minus 15, find the value of x. Well, angle WXV is this angle right over here. There's WXV. And what kind of angle did we say that was? Put a marking on it there. What kind of angle is this? It's a right angle. How big is a right angle? 90 degrees. So I can take where it says the measurement of angle WXV, and I can replace that with 90 degrees because I know exactly how big that angle is. And that is equal to 3x minus 15 degrees. So I can drop the degrees symbols. 90 equals 3x minus 15. And then we can solve this for x. We're going to add 15 to both sides. 90 plus 15 is 105. And then we divide both sides by 3. 105 divided by 3 is 35. So x is 35. For part D, it says that wy is 2x minus 9. So let's go find that on the picture. Wy, this distance right here, is 2x minus 9. And this segment over here, WZ, is 6y, sorry, not x, 2y minus 9. My apologies, I read that variable wrong. It's 2y minus 9. The other one is 6y minus 28. Well, what were we told at the beginning about wy and yz? I circled it in blue. What were we told about wy and yz? That they are equal. Wy is equal to yz, so then I can substitute in the expressions that they gave me. In the place of wy, we can put 2y minus 9. In the place of yz, we can put 6y minus 28. Then we're going to solve this for y. First thing we need to do is get our y's to the same side. So I would subtract 2y from both sides. So I'd have negative 9 equals 4y minus 28. Then we're going to add 28 to both sides. Oh, wait. Yeah, sorry. This says WZ, and I wrote YZ. I am so sorry, guys. Let me erase that. Back up. What they gave us, and what I blew right past as I was reading it, it says WZ equals 6y minus 28. So when I look at the picture, WZ is this whole thing here. That's 6y minus 28. We knew from up here that WY and YZ were the same size, but what is the relationship between WY and WZ? What do we know about these two again? They're equal. So what would I need to do to this if I wanted to get the whole thing? Multiply it by 2. So 2 times WY is equal to WZ. So 2 times 2x minus 9 is equal, sorry, not x, it's y. I keep writing x. 2y minus 9 is equal to 6y minus 28. Then we're going to take and distribute. So I would have 4y minus 18 equals 6y minus 28. Now I get my y's to the same side. So I'm going to subtract 4y from both sides. I get negative 18 is equal to 2y minus 28. Add 28 to both sides. And that would give me 10 equals 2y. Divide both sides by 2, and I get that y is 5. Moral of the story is carefully read what you have. I knew about a congruence. I didn't pay attention to it super well, and so I set up my equation incorrectly, which would have given me the wrong answer in the end. Please make sure that you take the time, unlike what I did, to identify on the picture what it is that you've been given so that you know how to set up your equation. What else would you guys like to see? Which one? 40, absolutely. We're going to find the values of x and y in the picture. So what I know down here is that angle C is 60 degrees. I don't know how big the other two angles are, but I do know, because of these congruence marks right here, that this is an isosceles triangle. Which means it has two congruent sides and two congruent angles. The way I find the angles that are congruent to each other is going to be across from the congruent sides. So BC is one of my congruent sides. That means angle A is one of my congruent angles. And AC is the other congruent side. That is across from angle B, so that is my other congruent angle. So I could, since angle A has 4y plus 12, I know that angle B up here is also 4y plus 12. And I can use my triangle sum theorem so I would have the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. Angle A is 4y plus 12. Angle B is also 4y plus 12. And angle C is 60 degrees. Set that equal to 180. I'm going to combine my like terms together. So I have a 4y and a 4y. That's going to combine together to give me 8y. And then we have 12, 12, and 60. What is 12 plus 12 plus 60? 84. So 8y plus 84 equals 180. I'm going to subtract 84 from both sides. I get 8y is equal to, what is 180 minus 84? 180 minus 84. How much? 96. Then we divide both sides by 8. 96 divided by 8 gives me what? 12. So y is 12. I didn't do x because I don't have enough information to find x. I needed to find my angles first to figure out what I was going to do about those sides. Let me scoot all of this over a little bit so that I have room for us to find x. All right, so to find x, I have to know whether or not these two sides are congruent. I know these two sides are congruent. If these two sides are also congruent, then I can set those expressions equal. I only know about this angle, 60 degrees. If I could find another angle that was 60 degrees also, then I would know that this side over here is congruent to that one. So let's take and substitute into 4y plus 12. 4y plus 12, and we just found out that y was 12. So I have 4 times 12 plus 12. This is for the measurement of angle A. What is 4 times 12? 48. And 48 plus 12 is how much? 60. Measurement of angle A is 60 degrees, which means angle B is how big? Also 60 degrees. So all three angles are the same size. When you have all three angles that are the same size, what kind of triangle is it? Equilateral. This is an equilateral triangle, which means all my sides are congruent. So it's not just AC is congruent to BC, but it's also congruent to AB. AB is congruent to BC. And what can I do with things that are congruent? Set them equal to each other. AB is equal to BC. AB is 2x minus 1. BC is 3x minus 7. And then we're going to solve this for x. So first thing I'm going to do is get my x's to the same side. I have -1 equals x minus 7. And then I would add 7 to both sides. I get 6 is equal to x. Yes. Yes. What other problems would you guys like to see me work through? Which one? Number 1? Absolutely. Problem number 1. It's really, really important that we use appropriate notation. So for array, we have a line with an arrow over the top. For a segment, we have a dash with no arrows over the top. And for a line, we have a dash with arrowheads on it. Part A says we need to find an array that contains point E. Well, here's point E. So I could do an array that's going this way. That would contain point E. Or I could do an array that's going this way. That would also contain point E. So some of the different correct answers, because there are multiple correct answers here. I could say EJ with a line and an arrow over the top. I could say EF. I can say JE. I could say FE. And then the last one that would be correct seems a little bit confusing. FJ would also be a ray that contains point E. That ray would have me starting here at point F, and it's pointing this direction. And because of the arrow on this end, it would continue on this path, which means it would eventually run into point E. So point E would be on that ray. For part B, we want to name a line that contains point F. So we could do line FJ. We could do line FE. And we could even do line EJ. Remember, with lines, it doesn't matter if my letters get flipped around, it's the exact same name. With rays, that's not true. When I flip the letters around, it is a different ray. But with lines, because it continues on in both directions forever and ever, It does not matter if I flip those letters around. So EJ would contain point F because it continues forever in both directions, which means as it continues on in this direction, it is going to intersect with point F. You only needed to give one name to get these correct. I'm giving all the possible correct answers here, but you only needed to give one. Part C, a line segment containing the point G. So we want to include this point right here. So I could have the line segment GJ or JG, because on line segments it doesn't matter if I flip them around backwards. Or we could do HG or GH. Because line segments stop, I could not have HJ, because that would stop at those two pieces and it would not continue on and contain point G. 3 collinear points. These points have to all be in a line together. And so points E, J, and F are all in a line together. Or we could do H, J, and G. Part E, we want an angle containing the point H. So I could do angle HJE. Please make sure you remember your proper notation for the angle. Or you could do angle FJH. If the first and third letters switch around, it's still describing the exact same angle. 3 non-collinear points. Now I want 3 points that are not all in a line together. So H, J, and E are not all in a line together. H, J, and F are not all in a line together. E, J, G are not in a line together. G, J, F. I could keep going on and on and on, but like H, E, G. There are many more. I could still do a couple more, but I'm going to go ahead and stop there so that we can get to the other 2 parts. A pair of vertical angles. So I could do this angle up here and this angle down here. So EJG, angle EJG, and angle HJF. Please make sure that you are using proper angle notation. There is another correct answer here. You could do angle EJH and angle GJF. So either of those would be correct. Angles that form a linear pair. So now we're looking for 2 angles that are side by side and together they form a line. So you could do angle EJG and angle GJF. Those angles are side by side. They share this side and together they make this line right here. You could do EJG and angle HJE. That would be this angle here and this angle here. You could do angle HJF and angle GJF. That would be this one and this one. Or you could do HJF and EJH. That would be these two angles right here. They share this side. Together they form this line. Couple things I want you guys to take note of, because it is improper notation that I'm still seeing at the end of the semester, and by this point this should not be a thing that is confusing anymore. Rays, lines, and line segments. 2 letters only. If you only have 2 letters, it cannot be an angle. An angle is either written with 1 letter in a situation where, like if I have a triangle and those vertices are called like A, B, and C, I could call this angle here angle A, or I could call it angle BAC, but I could not name it with 2 letters. I could not call that angle AC. We can never name angles with 2 letters. Yes. Angles, again, either named with 1 letter or 3 letters. Rays, lines, and segments, 2 letters only, always 2 letters. I was noticing on the last test there were several places where people named an angle with 2 letters, or they named a segment with 3. That is across the board incorrect and will be marked as incorrect. So please make sure you're using proper notation and the proper number of points. What else would you guys like to see? 35, absolutely. If triangle ABC is congruent to triangle DEF, okay, I'm going to stop right there and I'm going to draw those triangles. All right, I've got 2 triangles now, and we're going to label them. One of them is A, B, C. The next one, notice they're congruent. That's giving me a lot of information. It's telling me which angles are congruent to which other angles. I know that A and D are congruent to each other. So I'm going to put D right here, and I'm going to mark it as being congruent to angle A. I know that angle B and angle E are congruent, so I'm going to put angle E up here, and I'm going to mark it as being congruent to angle B. And then angle C and angle F are congruent. So C is here, I'm going to put F here, and I'm going to mark F congruent to angle C. My congruent statement doesn't only tell me about the angles that are congruent, it also tells me about sides. AB, first 2 letters, is congruent to DE, first 2 letters. So this side here is congruent to this side here. Last 2 letters, BC, is congruent to last 2 letters here, EF. So BC is congruent to EF. And then first and third, AC is congruent to first and third, DF. Right, now I'm going to look at the information that they gave me. Segment AB is 10x minus 9. Segment DF is 4x plus 12. And segment DE is 2x plus 7. We need to find the value of x and the length of AC. Well, to find the value of x, I need to match up something on the first triangle that's congruent to something on the second triangle. Which pieces are congruent that I could use? AB is congruent to what? DE. And what can we do with things that are congruent? Set them equal. So AB is equal to DE. AB is 10x minus 9, so I'm going to substitute that in. DE is 2x plus 7, so I'm going to substitute that in. And then we're going to solve this for x. First thing we do is get our x's to the same side, so I'm going to subtract 2x from both sides. So I would have 8x minus 9 equals 7. Add 9 to both sides. So 8x is equal to 16. And then I would divide both sides by 8. And I get that x is 2. How can I use that now to help me figure out how big AC is? Is there anything that we know of that's the same size as AC? DF. AC is congruent to DF. So AC would be equal to DF. And how big is DF? 4x plus 12. And we just figured out that x is how big? 2. So I'm going to have 4 times 2 plus 12. 4 times 2 would give me 8. And 8 plus 12 is how much? 20. So segment AC is 20. We probably have time for 2 more. 42, absolutely. In triangle ABC, AB is 6, BC is 12. I'm going to go ahead and draw myself a little triangle here. I'll call this A, B, A. It doesn't really matter where we put this, but I'm going to label it like this. A at the top, then BC. AB is 6, BC is 12. What two values does AC need to be between? So for our lower boundary, we do the difference between the two sides that we know. So I would do 12 minus 6. So my lower boundary is 6. So as I'm writing the two numbers that AC needs to be in between, 6 goes on the left-hand side because it's the smaller piece. To find the upper boundary, we add the two numbers that we've been given. So I would do 12 plus 6. And 12 plus 6 gives me 18. So AC has to be smaller than 18. It cannot be exactly 18 because it doesn't have the or equal to sign underneath it. It has to be smaller than 18. So 17.99999 is fine, but 18 is not. 19 is not. Has to be bigger than 6. So 6.000001 is okay because that's bigger than 6. But if it's exactly 6, that's too small. If it's 5, that's too small. It's got to be bigger than 6, but smaller than 18. What else would you guys like to see? We have 7 more minutes. That's probably time for one more problem. Does anybody have one more that they want to see? Which one, 38? Absolutely. 38, complete the 2-column proof. I'm going to take all of my given information. I'm going to put it in this first box here because that's where it says my given is going to go. D is the midpoint of FH. And FE is parallel to GH. So this is the midpoint. FE is parallel to GH. Well, if D is the midpoint of FH, then what do I know that I could write down about things that are congruent? Yes, FD and DH are congruent. FD is congruent to DH. That would be my midpoint theorem or definition of midpoint. I would accept either one there. Interesting. If FE is parallel to GH, then what kind of a shape should I draw? A Z. So I can draw a Z that looks like this. And when I draw that Z, it helps me find what? The inner corners. And what do we call those inner corners? Does anybody remember? Alternate interior angles. So I know that angle F and angle H are congruent. I could have drawn my Z the other way. I could have drawn the Z this way, and that still uses FE and GH. So I could also have said that angle E is congruent to angle G. Both of those are using alternate interior angles theorem. Is there anything that I'm allowed to mark that I wasn't given? D, either side of D, because these two angles that I just marked are what type of angles? What'd you say? Vertical angles. Angle FDE is congruent to angle HDG. You cannot just write angle D is congruent to angle D because I don't know which angle D you're talking about. That's our vertical angles theorem. And then finally, at the end, we can say that triangle FDE is congruent to triangle HDG, this piece that I was asked to prove. Please don't ever write prove as a reason. Prove is not a reason. Prove is what you're doing. There are two different reasons that I could use here. I could use angle, side, angle to say that these two triangles are congruent. Again, I would have angle, side, angle. Or, does anybody see the other one that I could use here? Angle, angle, side. Angle, angle, side. We could use angle, angle, side. All right. Please make sure that you turn in your pink cheat sheets before you leave the room today. If you don't turn it in, you can't use it on the exam tomorrow.